Dear students, welcome to Chapter 5. Chapter 5 is divided into two parts. Part 1 will be test of significance, and Part 2 is on hypothesis testing. Let's look at the objectives for this chapter. By the end of this chapter, students should be able to estimate mean and standard deviation of population from sample data and compute statistical confidence interval of mean and standard deviation from sample data. So this is part 1, and part 1 covers tutorial A. Now for part 2, which is a major part of chapter 5, the tutorials will be from B to G, and in that we will be dealing with conducting hypothesis testing and also understand the application of students' t-distribution. The keywords for this chapter are confidence interval, significance level, statistical estimation, and hypothesis, null hypothesis, alternative hypothesis, and students' t-distribution. Statistical estimation is about taking samples from a large population in order to reveal important information pertaining to the population. We can obtain an estimate of key population statistics, such as the mean and standard deviation, from sample statistics. Although population may refer to people inhabiting a certain place, in statistics, population can refer to any group which we wish to obtain information about. The group can be a product, people, or a phenomenon. The population size is assumed to be infinitely large. Thus, population statistics follow the normal distribution. The sample size is variable. It can be small, smaller than 30, or large, equal or greater than 30. When the sample is large, the sample statistics also follow the normal distribution. One way to obtain the population mean and standard deviation is to make measurements on the entire population, but this is very time-consuming and expensive. The realistic way is to take a large representative sample, obtain the sample mean and sample standard deviation, and from these, estimate the population mean and standard deviation using normal distribution. Note the symbols used to denote population and sample statistics. For population size, capital N, compare versus sample size, small letter n. And then the mean, standard deviation, and proportion. Note that for population, we are using the Greek letters, whereas for sample statistics, we are using the English alphabets. So mean is mu versus x bar, standard deviation, sigma versus the letter S, and proportion is pi versus the letter P. A realistic and practical approach to obtaining population mean mu is to estimate it by taking a large representative sample and using the sample mean x bar and sample standard deviation S to calculate for mu. The key equation in chapter 5 part 1 is shown here. The equation states that population mean mu is estimated to be in the range of plus and minus amounts of x bar. Now a word of caution here. Do not be confused with the Z formula used in chapter 4. In chapter 4, the population statistics used for your calculations are given as established statistics. In chapter 5, however, we have not established these numbers yet, which is why population statistics here is expressed as a range. Note also that sample size n is an important factor in this new equation. The basis for confidence and probability is based on what we already know about normal distribution. Let's use 95% probability as an example. We can say with confidence that the population mean is somewhere in the range between x bar minus 1.96s divided by square root of n and x bar plus 1.96 divided by square root of n. Now for simplicity, let's just refer to these two limits as just x minus and x plus. In other words, We can also say that there is a 95% probability that the population mean lies between x minus and x plus. Question: what is 1.96? 1.96 is the Z value. What is the Z value? It is the value corresponding to 95% probability. Refer to the normal distribution table on page 6 of your handbook. Recall how we obtain Z values from the standard handbook, page 6. If we are talking about 95%, then half of 0.95 is 0.475. You can see that the Z value is 1.96. Similarly, the Z values for frequently used percentages such as 90 and 99% can also be obtained. Table 5.1 shows the Z values for corresponding confidence levels. Besides estimating population mean, another one of our stated objectives was to estimate population standard deviation. This formula on page 5.5 is used for estimating population standard deviation. We will also have examples on performing calculations using this formula in the tutorial.